Okay, hi. How are you? Yes, today I'm going to have a lecture on advanced mathematics from sixth topic called complex number. And my name is Salom Khalid, professionally a mechanical engineer. And I hope you're going to enjoy this simple lecture on complex numbers. Okay, let's go now. As we know that complex numbers, the square root of a number is always non-negative, and for example, if you take 4 square is equal to 16, and negative 4 square is equal to 16 as well. Hence the square root of 16 is plus or minus 4. Okay, now what about the square root of a negative number? Okay, it is clear that negative number cannot have a real square root. And because of that, a scientist called Euler was the first mathematician to introduce the symbol I for the positive square root of a negative number, like negative 1 and so forth and so on. And that's so IE is equal, the I square is equal to negative 1. The solution for, let's take an example for the solution for the quadratic equation ax plus bx plus c, which can be obtained by the formula below. So we have negative b squared plus or minus b squared minus 4ac divided by 2a. And then if we have example 1, if we want to solve this equation, then we have negative 9 plus or minus square root of this 9 is not negative there, there's a typing error, so it's 9 squared minus 4 times a is 2 times 7, which is c, and then divided by 2 times 2, which is a. And then by simplification of the above equation, we have negative 9 plus or minus square root of 25. And this is going to be very simple because 25 is the positive number, so it has got the real square root. So if we simplify this one, and then we have x is equal to negative 1, no, x is equal to 1, or x is equal to negative 7 over 2, which is simple. But let's see example 2, of which we have 5 squared minus 6a plus 5, 6x plus 5 is equal to 0. So let's call it equation number 1. Same way we used the quadratic formula above, and we have, if we plug in the numbers, we have 6 is square, 6 plus or minus square root of, now this is negative 6, then squared, minus 4 times a is 5 times c is 5 as well, divide by 2 times 5, which is a now there. Okay, on simplification we have that equation, and furthermore we have 6 plus or minus negative 24, no, sorry, negative 64. And now it is becoming so confusing when we have the square root of a negative number, as you can see above. So this is where now Euler introduced his symbol I, which stands for the square root of negative 1, in which negative 64 square root cannot be presented by an ordinary number. Then we have to simplify like the way you can see, in which negative 64 squared is equal to negative 1 square root of a negative 1, and times 64 squared, in which we have the positive number of the square root of a positive 64 is 8, but this negative 1 remains as it is. And now we have that symbol introduced by Euler, which is I is equal to the square root of a negative 1. Then on simplification we have 8i. So this is not an ordinary number. That's why we have the complex number. So the solution for the equation 1 above is going to be x is equal to 0.6 plus 0.8i because of this negative, and then O x is equal to 0.6 minus 0.8i because of this negative. Since I stands for -1 now, square root, hence I square is equal to -1. So using that symbol I square or I, we have different values of I cubic for the I cubic, fourth root, and so on, fifth root of fifth square, the fifth root of a number. We have different, the power, the fourth power, we have fifth power, and so forth and so on. So the power of I reduces to one of these numbers. We have 1 I is equal to square root of -1 I square, and then I then the fourth power, third power, and then so on. Now it can be deducted that number of the form a plus ib, where a and b are real numbers, are called complex numbers. So when you talk about complex number, it's the number of the form a plus ib, where a and b are real numbers. Note that a plus ib cannot be combined any further. In such expression, a is called real part of a complex number, and b is called imaginary part of a complex number. Therefore, complex number is equal to real part plus imaginary part. So let's check on complex numbers rules. Rule number A: a number which can be written in the form of a plus ib, where a and b are real numbers, and I is equal to square root of -1, is called complex number. B: if z is equal to a plus ib is a complex number, then a and b are called real and imaginary parts respectively of a complex number, and written as real part of z is equal to a, and the imaginary part of z is equal to b. Order relations greater than and less than are not defined for complex numbers. If the imaginary part of a complex number is 0, then the complex number is known as a purely real number, and if the real part is 0, it is called purely imaginary number. For example, 2 is purely real number because imaginary part is 0, and 3i is purely imaginary number because the real part is 0. Yes, let's go on the operation of complex numbers. Let's start with addition and subtraction. Example, we got 4 plus 5i plus 3 minus 2i. We have to correct the like terms. So we take an example like we correct 4 plus 3, as you can see, and plus on bracket 5i minus 2i. So on simplification of this one, we have 7 plus 3i, which is very simple like that. And example 2 like that, we use the same way we have done in the first example and collect the like terms, and we have 4 minus 2 plus bracket 7i plus 5i. Okay, and the answer is 2 plus 12i. It's called complex number. Generally, a plus ib bracket plus bracket c minus plus id is equal to a plus c plus and bracket I b plus d. Okay. Yeah, that's simple on addition and subtraction of a complex number. So now we go into multiplication and division of complex numbers, same way as we have done in subtraction and addition. This is very simple. It's like we are multiplying normal numbers, but later on we'll correct the like terms and so on. So let's take an example of 3 plus 4i in bracket times 2 plus 5i. Then we simplify as a normal number. We have this simple equation here, and then 6 plus 23i plus 20i squared. And then on simplification, we know that I squared is equal to -1. Then we have 6 plus 23i's minus 20. Okay, and then more simplification, we have this minus 20. 6 minus 20 is going to be -14 plus 23i. So it's simple like that. Same applies to this equation here. Example number 2, we have 3 plus 4i times 2 minus 5i, and then we simplify. The equation becomes 6 minus 15i plus 8i minus 20i squared. And then we have more simplification. 6 minus 7i, this and this we collect the like terms, but this I squared is equal to -1, as we have seen above. And then we have 6 minus 7i plus 20. Okay, more simplification, we have 26 minus 7i. Okay, note any of the complex number of the form a plus or minus b minus ib has the product which is real. So which means when we multiply these two numbers, we have the product which is real. We can see the example below, i.e. a plus ib times a minus ib is equal to a squared minus abi plus abi minus bi squared. So when we simplify, we have this one, ab and ab cancels each other. This is negative, this is positive, and b we have b squared, we have I squared. Then I squared is equal to -1, and negative cancels each other. So then we have a squared plus b squared. That's simple. So such complex numbers above are said to be conjugate. Each is the conjugate of the other. So which means a plus b plus ib is the conjugate of a minus ib, and vice versa is also true. Hence, if a plus ib is denoted by z, then the conjugate negative ib is denoted by z bar, as you can see, z bar, i.e. z. If z is equal to a plus ib, then the conjugate, which is z bar, is equal to a minus ib, because the conjugate of a complex number. So division will also be done by multiplying numerator and the denominator by the conjugate of the denominator. You can see the example below. Example, we have to find the division of this one. We have to simplify this one. 2 plus 9i, okay, divided by 5 minus 2i. Then we have to simplify that one, and the division is going to be done by the conjugate of this denominator, and then we multiply that conjugate to both denominator and numerator. So we multiply 2 plus 9i times the conjugate of this one, which is 5 plus 2i, divided by 5 minus 2i times 5 plus 2i. On simplification, we have 8 divided by 29 and plus 49i divided by 29. Okay, note the complex number is 0 if and only if the real term and the imaginary term are each 0. i.e. x plus iy is equal to 0 if x is equal to 0 and y is 0 as well. Suppose a plus ib is equal to c minus plus id. Then a plus ib minus, in bracket, c plus id, then it is equal to 0. So for that case, a is equal to c and b is equal to d. Thus two complex numbers are equal if and only if the real terms and the imaginary terms are separately equal. Example, find the values of x and y if x plus yi is equal to 3 plus I in bracket times 2 minus 3i. Okay, we do the same simplification as we have done on multiplication above, and this is going to be simple. We simplify the right hand side, and we have 6 minus 9i plus 2i minus 3i squared, and then on simplification we have 6 minus 7i plus 3, and we have 9 minus 7i. So we compare x plus yi is equal to 9 minus 7i. Since we equate between the real part and the imaginary parts, because these numbers are equal, so x is going to be equal to 9 for the equation to balance, and y is going to be equal to negative 7. Simple like that. And we have this example as well, and we have to simplify the left hand side so that we can have the values of x and y. Okay, we simplify like that. Okay, and 2 plus 5i is equal to x plus yi bracket times 1 minus I. And on simplification, we simplify the right hand side, and then we have x minus that much and that much, and then we have 2 plus 5i is equal to x plus y minus x and bracket I. And now we compare two equations, real part and imaginary part respectively. Okay, x plus iy is equal to 2. This is real part and this is real part. And then we take the imaginary part, which is negative x plus y, as you can see, is equal to 5. This is imaginary part. And then we simplify that when we solve the simultaneous equation as normal. And then this is going to be, when we plus these two equations, this x and negative x cancels each other, then we have 2y is equal to 7, and then there is going to be y is equal to 7 over 2, and x is equal to negative 3 over 2. That's very simple like that. Okay, the last slide is going to be to show that 1 plus I is the solution for this equation below. And the solution is going to be like this. We have x squared minus 2x plus 2 is equal to 0, and then let's call equation number 1, and then let's use the quadratic formula to solve this equation above. And we have b is equal to negative 2, is b is negative 2 plus or minus negative 2 squared minus 4 times a is equal to 1 times 7, which is no, this is times 2. Sorry, this is gonna be times 2. This is gonna be times 2. Sorry, because c is 2 as well. So this is gonna be times 2 there. This is gonna be times 2 times 2. Yes. Okay, that's cool. And it's going to be times 2 there. And on simplification, we have we have 2 plus or minus 4 minus 8, which is right, and divide by 2. So x is going to be 2 plus or minus negative 4 squared. As we know that I is equal to square root of a negative 1, and then we plug into the above equation. So we have x is equal to 2 plus or minus 2i divided by 2, and then we have I, we have 1 plus or minus I. So we were asked to show that 1 plus I is the solution for this, one of the solution for this equation. So now we see that x is equal to 1 plus or minus I. So So 1 plus I is 1 among the solution for the question 1 above. So it's shown. Yeah, that's the introduction of a complex number. This topic is the topic in which its question appears on paper 2 of advanced level exams. So I hope you enjoyed this lesson, and next slides or next lecture we are going to show different other parts like Argand diagrams and graphical presentation of a complex numbers on a yeah, like that. So I hope you enjoyed this simple lecture, and yeah, welcome. Don't forget to subscribe in my YouTube channel, and okay, bye bye, see you later.